Okay, in this last video I want to talk about the two graphs here, and we need to label which one is the function f of x and which one is the derivative f prime of x appropriately. And then we have to give some specific points of evidence for your decision. And you can start anywhere and look at anything, but you do have to be careful. You have to make sure that you can't find any counterexamples to go against what your conclusion is. And what I might do is just start from left to right. Maybe first what I'll do is just go over a couple of the facts that we need to deal with this. The first one is that when f of x is increasing, when the original function is increasing, the derivative must be positive, and that works vice versa. When the derivative is positive, then the original function f of x must be increasing. Second, when the original function is decreasing, then the derivative f prime of x has to be negative, and it works vice versa as well. When the derivative is negative, then the original function f of x is decreasing. And finally, when the original function f of x is stationary, then the derivative has to be 0, and that works vice versa as well. When the derivative is 0, then the original function has to be stationary. It doesn't have to have a max or a min. It could be passing through just a stationary point. That first little curve there is an example of at the max point of that, of where the derivative is 0 and the original function is stationary and passes through a maximum. Then the second curve shows at the minimum point there where the derivative is 0 and the original function is stationary and passes through a minimum. And the third example is that in the middle there, the function is stationary, but it doesn't pass through a maximum or a minimum there, but the derivative would still be 0. Alright, so let's use those three facts to analyze the function for a moment. If I were to start by looking at this, the bold or the dark function graph, then I can see that it's decreasing. I have a definite interval on which that function is decreasing, and since that's decreasing, the derivative of that function has to be negative throughout that entire interval. And so at least I can see that I have this interval here where the darker function is decreasing, and if that were the original function, then the lighter function should be negative throughout that whole time, but we see that it's sometimes negative on that interval and sometimes positive. To me, that's enough for me to know that the darker function is not the original function. So that means to me that the darker function has to be the derivative and the lighter function has to be the original function. So that's going to be my guess just by looking at one piece of evidence like that. But then I need to go on and find I'm going to look for 3 points of evidence here. So let's see what I might say. Okay, well, I'm going to look at this since I'm thinking that the lighter function is the original function. I'm looking at this particular interval that's like from -8 down to -5 for x values from -8 to -5, that function is decreasing. And it turns out that the purple function, well, that purple I highlighted in purple, the derivative function is definitely negative over that interval. So one piece of evidence might be that f of x decreases on -8 to -5, and f prime of x is negative there as well. Now another point is that at x equals 0, f of x is stationary there, the light function, and the derivative is 0 there. The darker function definitely doesn't have a 0 derivative there, and yet the lighter function is 0. Then when x equals 2, f of x is stationary there, and the derivative is 0. That's another point of evidence as well.